Okay, let's start this class. So first of all, this electronic configuration, right? This is a difficult task for each and everyone to understand this. Is what is this electronic configuration, right? So we have drawn the electronic configuration for what? H2 molecule, right? H2 molecule. Like one H atom will be combining with another H atom, right? So it will be forming what? H2 molecule, right? So one S and one S is combining, right? Yes or no, guys? One S and one S is combining. So it is making what? 1s and sigma. This is what? Sigma 1s and sigma star 1s. Getting my point, everyone? What is it? So now if I will be asking that whether sigma star 1s will be having the higher energy or sigma 1s will be having the higher energy. Please write in the chat section, guys, which will be having the higher energy. Kaniska, Atachaya, which will be having sigma star. Anil Devi only writing. Atachaya and Kaniska, why are you not writing? Sigma 1s will be having the higher energy. Kaniska, what do you say? Kaniska, what do you say? Please write in the chat section. Do fast. No answer. Sigma 1s, wrong answer. Always I have told you that sigma star 1s will be having the higher energy. Sigma star 1s will be having the higher energy because this is what? This is anti-bonding, right? Wherever there will be anti-bonding, there will be what? There will be more energy will be there. Wherever there will be bonding will be there, so that will be having the lesser energy because they are more stable. Getting my point? Easy. So you can see here that from bottom to top, the energy is increasing. Getting my point? So sigma star 1s will be having higher energy than sigma 1s. Getting my point? Easy. Now, if I want to find the bond order of what? Bond order of H2 molecule, right? So what is the bond order? First of all, try to understand here. What is this bond order? Anyone of you who is knowing about the bond order? Nilambri, please turn on your camera. Bond order, who will be telling me? Natasha, can you please tell me what will be the bond order? Anil Dev, can you please raise your hand that whether you are knowing or not? Bond order. No, sir. What is the formula for finding the bond order? What is the formula for finding the bond order? Bonding minus anti-bonding upon 2? What do you say? Bonding minus anti-bonding upon 2? So what is the bonding? What is the bond? See here. If I will be seeing here, if I will be asking you about the H2 molecule, so what will be that? H2 molecule. If I will be asking about the H2 molecule, then what will be the bond order for this? See guys, H2 molecule bond order will be what? Although we will be learning these things in the later part of the class, number of bonds. Yes. So the bond order will be what? If I will be asking about the H2 molecule bond order, so it will be 2 minus 0 upon 2. What do you say? It will be 1 only. So how this will be 1? How this will be 1? Can you please say me? How this will be 1? Anyone? Yes, Pranab, please tell me.
Sir, the formula of bond
Yes,
order is like half into bonding electrons and anti-bonding electrons. Bonding
electrons minus anti-bonding electrons, right?
Yes, sir.
Upon half, upon 2.
Yes, sir. So here no anti-bonding electrons, but there's 2 bonding electrons. So by applying formula, it
so
will
you
be
can
like,
see here. So you can see here there is no any. So there is no any anti-bonding electrons are there. There are only bonding electrons are there. There are 2 bonding electrons are there. So if there will be 2 bonding electrons will be there, so 2 minus 0 upon 2, that will be the bond order only. So what will be the formula that we will be drawing? Bonding order. Bond order equals to bonding electrons. You can say bonding minus anti-bonding, right? Anti-bonding, right? Electrons upon 2. Can we say this or not? Yes, guys. Is it fine? Let's suppose if there could be 1, then 2 minus 1 plus 2 minus 1 upon 2. Yes or no? So the bond order can be either 1, 2, 3, or even in fractions as well. Getting my point, everyone? So are you comfortable now? Who all are comfortable? Can you please tell me? You were having your PTM today? Yes, Bhuwana. You were having your PTM today. Okay. So have you joined this today or not? Aniska? Joined? Atachaya? Joined? Good. Okay. Fine. So I hope everybody now got this point. This is the reflection part. This is what? This is reflection part. We have learned about this in the previous classes. How will be the hybridization? How will be the bond angles? What will be their shape and geometry? Everything we have learned in the last classes, right? So even if now I will be going to ask, so how many people will be going to give me the answer? I don't know, but I have to ask. AB3L, the hybridization will be what? Atashaya will be giving me the answer of this question. AB3, question is what? AB3L. SP3, are you? Anil, you don't have to give the answer. Atacha, I have asked from Atachaya. Are you Atacha? Anil Dev, your name is Atachaya or what? Please tell me that. No? So Atachaya will be giving me the answer of this question. So yes, Atachaya, please tell me. So AB3L, what will be the hybridization for this? AB3. Guys, it is really very easy, really very easy. See, what can be the hybridization? It will not take much time. See, you have to keep this A here, right? Write A here. And what is this B? B is 3, right? So like just put any bond here, right? If you are not knowing anything, right, just give a danda here. Getting my point? Just have a three bonds, or you can say 3 sticks or 3 anything that is given here, right? And one L is there. Although it is lone pair, but even this also is there, so you can write anything like this, right? Now, 1s, you are knowing that 1s can be there, and p, how many orbitals are there? 3 orbitals are there in p. You are knowing well. What about this p? How many orbitals are there in p? 3. 3 orbitals are there or not? Please tell me. And in D, there are 5 orbitals are there. In S, there will be 1. There in P, there will be 3. So the right answer will be what? Atachaya, can you please give me the answer for this question now? Okay. Yes, very good answer. So the hybridization will be what? 1S, and because there are 4 bond, you can say 4 bond is there. If 4 bond will be there, then sp3 will be there, right? Got my point? If I will be asking one more question, will you be able to give or not? Yes, sure. Giving me assurance. Guys, each and everyone have to try for this question, and please write your answer as soon as possible in the chat section, right? So please write here. The question is AB2L3 this time. Then write the answer for this question. If it is possible for you write the geometry, then please write the geometry as well. And if even possible for you to write the shape, then that will be also good. If you are not knowing this, at least you have to write the hybridization for this. Only few answers are coming. Why you are taking this much time? I don't know. Pranavar, I think that there is some problem in understanding this part, right, Pranav? Atachaya, what is your answer? Can you please give me the answer for this? Kaniska, where are you? Why the answer are not coming? Arti, Maurice, Bhuana, Mukeswaran. What will be the right answer for this question, guys? What do you say? What will be the right answer for this question? See, AB2 is there. First draw A, right? B is there. What? 2B is there. So draw B. There will be 2B, right? So you have to just draw single bond, right? And L3 is there, right? L3 is there. So L3 will be there. Although it will be a lone pair, but I have taken as a bond, right? So how many bonds are there? 1, 2, 3, 4, 5. 5 bonds are there. So 5 bond will be accommodated in what? 1s will be there, right? For 1 bond, 1s will be there. 3 bond will be for P. So SP. So 4 is there. So 1 will be taken from D. So can't it be like SP3D? SP3 trigonal bipyramidal, sir. Yes. Trigonal bipyramidal. Got my point, everyone? Atachaya, is it easy for you now? Can you please tell me? Where are you? Yes. Is this easy now? Easy. You have to just see the figure that whether it is what? AB2 is there, AB2L is there, AB2L2 is there, AB3L1 is there, AB3L2 is there, AB4L is there, AB5L is there, AB5L2 is there, AB5L3 can be there. Getting my point, everyone? Is it easy? Kaniska, what do you say? If I will be asking you in air, then also you will be able to give the answer or not? Without writing anything in your notebook, can you give me the answer for this or not? Kaniska, will you be able to give the answer in air? Yes. Will you try? Yes. So please turn on your mic. I will be asking you one question, and the next one will be Bhuana. You have to give me the answer in air only, right? The question is, if the molecule is AB3L, not AB3L, AB3L, AB2L2, AB2L2. So the hybridization will be what? I don't have to use your pen and pencil. People are trying. So you have to give me the answer before them. Nilamri, what do you say? Will you be able to answer this question? Kaniska, please do try. Please, it's a matter of my prestige, right? If you will be not answering, then it's a matter of prestige, right? So try to give me the answer in air only. AB2L2. AB2L2. Yes. Just concentrate. How many bonds will you form? 2 bonds will be there, and lone pair will be what? How many lone pairs will be there? 2 lone pair will be there. So if 2 bonds and 2 lone pair will be there, then what will be the hybridization for that? 1s and 3p. So sp3 only. sp3. Is it easy now? Nilamri, are you ready for giving me the answer in air? Yes, ready? So should I ask now? The question is AB3L2, not AB3L2, AB3L. Yes. Without using your pen and pencil, you have to just give me the answer in air only. Please turn on your mic and give me the answer. SP3D or SP3? SP3. Are you sure? So many people are giving me the answer. Atachaya, what do you say? What will be the right answer for this? Please turn on your mic, then please speak.
SP3, sir.
Yes.
SP3, sir.
Yes, SP3 will be the right answer. Nilamri, although you were also right, but you were not much confident. Got my point, everyone? Okay, fine. I hope you might have understood now. So how we can find the hybridization for this, right? Now, Now you will be seeing here that how the atomic orbitals are combining to form the molecular orbitals, right? How the atomic orbitals are combining to form the molecular orbitals. So there will be a bonding orbitals. So there will be a bonding orbitals, and there will be anti-bonding orbitals will be also there. Anti-bonding, right, everyone? Bonding orbitals will be there, and anti-bonding orbitals will be also there. Getting my point? So 1s and 1s will be combining to form 1s2, or you can say sigma 1s2. Getting my point, everyone? 1s and 1s will be combining to form 1 sigma 1s2, right? Because there will be what? There will be a overlap. That is what? There is a side overlap will be there, right? Or you can say head-on overlap will be there. Head-on, right? You might have seen collisions in that in the truck, in the road, right? You might have seen the head-on collision, or you might have learned in your physics as well. There will be a head-on collision will be there. So what is the meaning of this head-on collision? It means what? This is the collision. It is known as what? Head-on collision. Getting my point? So if head-on collision will be there, then the formation of sigma bond will be there. If there will be a collision of like this, so two body can attach like this as well, right? Attach like this. So if this collision will be there, so that will be what? There will be a formation of pi bond. Getting my point, everyone? So there will be a formation of double bond or pi bond, you can say. Clear here? Okay, now see here. So we will be going to see about that, how the electronic configuration. There are few points, guys, that we have to see, right? And after that, we will be solving some questions as well, right? Okay, fine here. So what are the points that are important for us is what? Electronic configuration and molecular behavior that we are going to see, right? First of all, the distribution of electrons moving various molecular orbitals is called electronic configuration of the molecule, right? Like how the electrons are distributed among the atomic orbitals and how they have combined to form molecules, that we will be going to discuss about, right? The electronic configuration of the molecule or the molecular orbitals energy level diagram gives the following information regarding the behavior of the molecules. About the stability, this is giving us, and what we are getting from there, bonding order, and what we are getting from there, bonding order, magnetic character, and what we are getting from there, that is, guys, I hope everyone is knowing that is BBDSP. Getting my point? So these things we are going to see from here, right, everyone? Am I clear here? And we have taken in today's class so many molecules I have taken, right? So how there will be the bonding, and what will be there, bond strength, what will be their bond order, what will be their configuration. Everything we will be discussing in today's class. Getting my point, everyone? So today's class is very important. Please concentrate on the board. I hope everybody will be able to understand now. So first of all, we will be going to see about the stability, right? So what do you say? If the bond order will be more, so more stability will be there, or the bond order will be less, then the stability will be more. Can you vote for this? If the bond order will be more, then the stability will be more, or when the bond order will be less, then stability will be more. Bhuana, what do you say? Anil Dev, what do you say? Atachaya, Mukeshwar and Morris, what do you say? If the bond order will be more, then stability will be more, or if the bond order will be less, then the stability will be more. What do you say, guys? Nobody is saying anything. So no, sir, not knowing, sir. Anil Dev, please, can you guess? If the bond order will be higher, then the stability will be more. If the bond order will be less, then the stability will be more. What do you say? 5 bond order will be more stable, or 3 bond order will be more stable? A compound having the 3 bond order will be having more stable in nature, or the compound having the bond order will be 3, they will be having the more stability. Let's understand in today's class, right? If you're not able to give the answer, no problem. We will be understanding in this today's class. See, stability of a molecule. The electrons in bonding molecular orbitals will give stability to the molecule, whereas those in anti-bonding molecular orbitals will decrease the stability. So this is a really very important point for you guys. Please have a note of this. If you are having your notebook or anything in front of you, please have a note of this. The electrons in bonding molecular orbitals will give stability the electrons in bonding molecular orbitals will be giving the stability, and the molecules where those in anti-bonding molecular orbital will decrease the stability. Getting my point, everyone? So in bonding, they will be giving the stability. In anti-bonding, they will be decreasing the stability, right? So that is what? NB is what? Bonding, right? So thus if NB represents the number of electrons in bonding molecular orbital, right? So NB is what? Number of molecules in bonding molecular orbital, right? Bonding molecular orbitals. And Na, anti-bonding molecular orbitals, right? If Na represents the number of electrons in anti-bonding or molecular orbitals, then there can be what? There can be some generalization method, right? NB, the molecule is stable. If NB will be more, right? Then Na, the molecule will be more stable. Yes or no, guys? If the NB will be more, then the molecule will be more stable, or even the molecule will be unstable if Na is, or you can say Na is greater than NB, right? Na is greater than NB, right? Then there will be what? There will be instability will be there, or even the molecule is unstable if NB is equals to Na, right? NB is equals to Na. Like anti-bonding molecular, right? The electrons present in the anti-molecular orbital and the electrons present in bonding molecular orbitals, if they are having the same number of electrons, then it will be called as what? They will be what? They will be unstable in nature. Getting my point, everyone? Everything is clear here? Now you can see here, more bonding molecular orbitals are occupied, and therefore the bonding influence is stronger, and therefore stable molecule is formed. Getting my point, everyone? Easy. Second one is what? The anti-molecule, in the second, the anti-bonding influence is stronger, hence the molecule is unstable. Got my point? Third is what? According to third, even the number of electrons in bonding molecular orbital, right? And the number of electrons in anti-bonding molecular orbitals are same. The atoms do not combine to form molecules. This is because the fact that the effect of anti-bonding electron is slightly more than that of bonding electrons. Getting my point, everyone? So what are the three conditions that we have to learn? That is what? Bonding molecular orbitals, where the number of electrons is more than the anti-bonding molecular orbitals, like the electrons present in the anti-molecular orbitals. So that will be more stable in nature, right? If the electrons present in more in amount in anti-molecular orbitals, so that then molecular orbitals, so then it will be what? Then it will be less stable. What do you say? It will be less stable then. So that will be also effect. There will be also effect in orders as well. Getting my point, everyone? Is it easy now? So now concentrate here. You can see here, NB is greater than Na. If NB is greater than Na, so the molecule will be what? Stable. So this is what? Bonding molecular orbitals. If Na, anti-molecular orbitals is greater, then it will be less stable or unstable, or even if they will be both will be equal, then also it will be what? Unstable in nature. Getting my point, everyone? Why in this case, if I will be asking, if Na equals to Nb, then also it is unstable. Can you say why? Can you say why? No. Nobody will be speaking this answer. Why this will be, if Na equals to Nb, then why there will be instability will be there? Because the anti-molecular orbitals, the influence of anti-molecular orbitals will be more, right? Even though the number of electrons are same, then also there will be the influence of what? There will be the influence of anti-molecular orbitals. So there will be a less stability will be there. Getting my point, everyone? You can see even this is because the fact that the effect of anti-bonding electrons is slightly more than that of bonding electrons. Now, how to find the bonding order or bond order? I have given you the triggers also. I have given you in the starting of the class, I have told you that is what? Bond order, sorry everyone. Bond order equals to what? That is what? Bonding minus anti-bonding. Number of electrons Guys, I am writing like this. Number of electrons in bonding molecular orbital in MOS. It is what? Not dominos. It is MOS. MOS. That is what? Molecular orbitals, right? Bonding molecular orbitals or electrons present in the molecular orbitals. Getting my point, everyone? It is not dominos, right? So bonding. So number of electrons in bonding molecular orbitals, right? Minus what? Number of electrons in anti-bonding molecular orbitals. So that is what? NB minus Na upon 2. NB minus Na upon 2. If this will be the condition, so we can find the bond order. Getting my point, everyone? Is it fine for you, everyone? Is it fine or not? Please tell me. Now, the bond order of 1, 2, 3 corresponds to single double. Suppose there will be a bond order will be 1. So it will be what? It will be related to the single bonds. If the bond order is 2, so it means there is a double bond is there. So there is a visibility of double bond will be there. If the bond order is 3, so there will be a presence of triple bond will be there. But the bond order may be fractional. So it doesn't mean if bond order is fractional, so it doesn't mean that the bond is fraction, right? There is a complete line that you are seeing in the bond, right? So there will not a half bond will be there. There will no any half bond will be there. Getting my point, everyone? Easy? Now, see here. Now, what information conveyed by rand and order, right? That we'll be going to see. If the value of bond order is positive, it indicates a stable molecule, right? If the value of bond order is positive, like 1, 2, 3, 4, it indicates a stable molecule. And if the value of bond order is negative or zero, it means that the molecule is unstable. Getting my point? If NB minus Na is what? 0, it is what? Unstable in nature. Or you can say NB minus Na upon 2 is 0, then also it is unstable in nature. Or NB minus Na is negative, that is what? Minus 2, minus 3 is coming, let's suppose. So then also it is what? Unstable in nature. Getting my point? Easy now? Any problem? No? Now, see here. If the value of bond order is positive, it indicates the stable molecule. If the value of bond order is negative or 0, it means that the molecule is unstable. The stability of a molecule is measured by its bond dissociation energy. Getting my point? Getting my point, everyone? So the bond dissociation energy is directly proportional. Bond dissociation energy is directly proportional to what? That is bond order. So more will be the bond dissociation energy, more will be the bond order. Or you can say greater the bond order, greater is the bond dissociation energy. Greater the bond order, greater will be the bond dissociation energy. Greater the bond dissociation energy. Getting my point, everyone? Easy or not? Please say me. Is there any problem? Any problem? No? What do you say, guys? Anil Dev, please turn on your camera. Pranav, please turn on your camera. Pranav, how many times I have to speak the same thing? See, guys, this is a simple rule of this class. Whenever you are in your live class, you will have to open your camera. So see, guys, I don't want to repeat the same thing. Don't waste my energy on speaking these simple things. This is your duty. If I'm coming, my duty is to teach you, your duty is to turn on your camera. Getting my point, everyone? Okay, now. So is it easy now? So if the bond order is maximum, so the bond dissociation energy will be more. Is it easy? Easy, everyone? Any problem till here? Okay. You can see here, if the bond order is equals to 3, has a larger bond dissociation energy, that is what? 945 kilojoule mole inverse. The oxygen molecule bond dissociation energy is 495 with the bond order equals to what? 2. So if 2 is having how much energy? 495, right? And 3 is having how much? That is 945. Getting my point? So the bond order is 3 is greater than the bond in bond order 2, or you can see the bond dissociation energy of second order, the bond order of third order is greater than the second one. Getting my point? C. BO, second bond order will be having lesser than third order bond dissociation energy. Bond dissociation energy, yes or no, guys? Easy? No. See here. The bond order is inversely proportional to the bond length. This is the important point that you should know. Guys, bond length. The bond order is inversely proportional to the bond length. Getting my point, everyone? So if higher will be the bond order, lesser will be the bond length. Easy? Higher will be the bond order, lesser will be the bond length. The higher bond order value, smaller is the bond length, right? You can see here, oxygen. Bond order is what? 2. Bond length is what? 121 picometer. 121 picometer. Nitrogen, bond order is what? 3. Bond dissociation energy is what? 945. Bond length will be what? 110 picometer. So it is lesser. It is lesser than what? Oxygen. Getting my point, everyone? Is it easy now? So if I will be saying that if the bond dissociation energy is more, then the bond length will be higher or lower? Who will be telling me the answer of this question? If the bond dissociation energy is more or higher or larger, so the bond order will be lesser or higher? Or if I will be asking, Kaniska will be giving me the answer of this question. Question is what? If the bond dissociation energy is larger, then the bond length will be what? The bond length will be what? The larger will be the bond length, or higher will be the bond length, or lower or smaller will be the bond length? Lesser. Yes, very good answer. Getting my point, everyone? So how they are interlinked? Getting my point? Bond order 2, right? Bond dissociation energy 495, right? And bond length 121. So how they are associated? Bond order, bond energy, or you can say bond dissociation energy, BDE, and bond length, BL. How they are associated? If bond order will be more, then larger will be the bond energy. If bond order is lesser, lesser will be the bond dissociation energy. If bond order is lesser, higher will be the bond length. Getting my point? If this is lesser, then this will be higher. If this is bond order is lesser, bond length will be higher. Getting my point, everyone? Is it easy now? Is it easy or not? Please tell me, everyone. Is there any confusion till here? So what is the relation between this bond order and bond dissociation energy and bond length? Okay, now Anil Dev will be telling me. Please turn on your mic. What is the relation between the bond dissociation energy, bond length, and bond order?
If the bond order is more, then the bond dissociation energy will also be more. If the bond dissociation energy is more, then the bond length will be less.
Yes. So there is a 3 relation between all these molecules, right? Atashaya, can you please explain once again that what is the relation between bond order, bond length, and bond dissociation energy?
Bond dissociation energy is more and bond length is lesser.
See, actually what happened, the half part of the things that you have told is that has been cut out, right? So
Okay.
repeat once again.
Bond order, if bond order is more, bond dissociation energy is also more, but bond length is lesser.
Yes, that's great. Yes, good. So now we are going to discuss about the magnetic and magnetic character, that is what diamagnetic and paramagnetic in nature. What is diamagnetic and paramagnetic that we are going to discuss? That is what magnetic character that we are going to discuss here. Getting my point, everyone? Is it easy now? We are going to discuss about what? We are going to discuss about magnetic character, or you can say that is diamagnetic nature or paramagnetic in nature. Easy one. See here, if all the electrons in the molecule of a substance are paired, the substance is diamagnetic, right? Let's suppose if I am making a atomic orbitals, right? Not molecular orbitals. If I am drawing a molecular and not molecular orbitals, if I am drawing atomic orbitals, if these all are what? These are half-filled orbitals. Yes or no? What do you say? These are half orbitals. Somebody might be thinking, oh, this is half orbitals. How this will be, sir? How you can say this is half-filled orbitals? I am saying these all have been filled. So it is filled orbitals, fully filled orbitals.
It is
Guys,
half filled, sir.
yes, half filled. One electron has been filled, guys. So it is half filled. But some people might be knowing that, sir, if it has been filled, you have given something inside this. So it is fully filled, sir. No, it is not fully filled. It is half filled, guys. Getting my point. Now, if it is half filled, so you can say this will show what characteristic? It will be showing a paramagnetic in nature, right? But if it will be fully filled, like two electrons will be filled inside this, then it will be called as what? Diamagnetic in nature. Getting my point? So this is the character that we are going to understand here. So according to the oxygen, if I will be asking you about the oxygen, so now Kaniska will be insisting me in this question, like oxygen, how many electrons will be filled in this p orbitals? How many electrons will be filled? See guys, 1s2, 2s2, this will be filled now, and 2p what? How many 2p will be there? 4, and 4 will be there, 2p2 will be there, right? Or what? 2p4 will be there. Hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, oxygen. It is coming at 8 number. So 2p4 will be there. Kaniska, what do you say? 2p4 will be there. So 2p4 will be there. So it will be filled like this, right? It will be filled like this. So if it is filled and even it is having the even number of electrons in their orbitals, so it must be what? It must be showing the diamagnetic in nature. It must be showing diamagnetic in nature. Yes or no? What do you say? If it is having a pair number of electrons, so it will be called as what? Diamagnetic in nature. But how the oxygen will be showing their paramagnetic nature, that I will be showing you here, right? So here, I will be playing one video as well for that. But first of all, try to understand from here, right? So if all the electrons in the molecule of a substance are paired, the substance is diamagnetic, right? So this oxygen must be what? Diamagnetic in nature, right? So diamagnetic. And what is the meaning of this diamagnetic? Diamagnetic means what? Repel by magnetic field. If it is a diamagnetic in nature, it will be repelled by the magnetic field. Getting my point? If it is a paramagnetic in nature, so that will be attracted by the magnetic field. Getting my point, everyone? Is it easy? If you are not understanding by this way, then I will be giving you another example. What is another example? If a people has been married, right? One is wife, one is husband, right? They have been married, right? So if another people will be approaching them to marry them, no, they will do what? Repel each other. Go from here. Simon, go back, right? So go from here, right? But if anyone is alone, so they will be doing what? They will be in search of people, right? So they will be attracting. So paramagnetic is what? They are unpaired. So if they are unpaired, so they will be in search of someone, right? So in the case of magnetic field, they will be attracting each other. Getting my point, everyone? Is it fine for everyone? Is it easy now? Okay, fine. Now see here. So you can see here, diamagnetic repelled by the magnetic field. On the other hand, if there are unpaired electrons in the molecules, the substance paramagnetic attracted by the magnetic field. Getting my point, everyone? Easy now? Now, you can see here bonding in some diatomic molecules, right? So how the bondings are there in diatomic molecules? H2 is what? H2 is what? It is what? Diatomic molecules. You might have learned in your 9th standard. There is atomicity is there, and that diatomic molecules O2 is also there, right? In the examples, like in the book only, that has been given, right? So if I will be going to ask you whether Ne is a diatomic molecule or not, or He is a diatomic molecule or not, Who will be giving me the answer of this question? What do you ask, sir? I was not good in 9th standard, sir. Now I have tried my level best in the 10th standard. Then I have done something well in 10th standard, sir. But I was not good in 9th standard, sir. Please don't ask question from there. Guys, what is the meaning of this? See, if I'm saying H2 is a diatomic molecule. Why this is a diatomic molecule? Because there is one electron in H2, right? And in H, right? And H can combine and to form what? Duplet, right? Can form duplet. But helium, if you will be seeing helium or neon or argon, they are what? They have already completed their octet, so they will be not existing. They will be not existing in what? In their diatomic molecule. Ne and Ne, Ne2 you will be not seeing anywhere. He2 you will be not seeing anywhere. Or Ar2 you will be not seeing anywhere. Getting my point, everyone? Why you are not seeing all these things? Because they already have completed their octet, so there is no requirement of anything for them. Getting my point, everyone? But H, they will be requiring. There will be a requiring of one electron to complete their duplet, not octet, duplet. Oxygen is what? Oxygen is having in the outermost, there is what? 6 electron is there. If another electron will be sharing their electrons, another O2 O will be sharing their electrons, then they will be combining to form the what? Stable molecule of O2. Getting my point? So 2 electrons will be shared in between them. Then only there will be a formation of octet will be there, and then only they will be become a stable, and then that form is existing in nature, right? Not only O molecule is existing in nature. Getting my point, everyone? Is it easy now? Okay, fine. So now, what about the hydrogen molecule that we are going to see here? Each hydrogen atom has one electron in 1s that we are knowing. Are you knowing or not? Oh, sir, what do you say? 1s in hydrogen, 1s is there. We are not knowing, sir. Knowing or not, guys? What do you say? So 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6. I have made you learn all these things so many times, guys. I hope you all are knowing now this. No. So hydrogen, right? Each hydrogen atom has one electron in the 1s orbital. Therefore, there are 2 electrons in hydrogen molecule, right? So there are how many electrons are there in hydrogen molecule, H2 molecule? So 1s and 1s2. So we'll be writing these things in the parallelly, right? 1s and 1s, right? So what do you say here? What do you say here? So what will be there? So 1s and 1s will be there, right? So, and therefore there are 2 electrons in hydrogen molecule. Both these electrons are to be accommodated in the lowest energy molecular orbital. Lowest molecular orbital. This is the lowest molecular orbital. That is what? Sigma 1s, right? Sigma 1s. So there will be a formation of sigma bond, H and S. Sigma bond is there. Single bond is there, right? According to Pauli's exclusion principle, these 2 electrons should have opposite spin. The molecular orbital energy level diagram of S2 molecule that you are showing, that we have seen. See here, this is not filled, right? That will be not filled. Getting my point, everyone? So there is a blank. So you can see here, there is no electron in the sigma star 1s. No. So the molecular orbital electronic configuration of S2 molecule is what? Sigma 1s2. Sigma 1s2. Getting my point, everyone? So the bond order will be what? NB, bonding minus anti-bonding upon 2. So there is no any molecule. So there is no any electrons in the. So there is no any electrons in the anti-bonding, right? There are only bonding molecule. You can see here in the diagram also. Here, if there will be a star means what? Is anti-bonding. Getting my point? If there is no any star is there, it means what? There is no any anti-bonding molecular electrons in the molecular orbital theory. If there is no any anti-bonding, so there is only bonding. If there is only bonding, so what is there? So what do we say? So we will be writing the formula what? 2 minus 1. There are 2 electrons in the bonding orbitals, right? So 2 electrons in the bonding orbitals minus 0 upon 2. So right answer will be what? 1. Getting my point, everyone? Is it easy now? Is it easy to understand? Pranav, what do you say? Easy to understand? Why the why the H2 molecule will be having the bond order 1 only? So bonding minus anti-bonding. So 2 minus 1 upon 2, it will be what? 2 upon 2, it will be what? 1 only. Getting my point?
Yes, sir.
Easy?
Yes, sir.
Fine. So see here, the bond dissociation energy of hydrogen molecule has been found 438 kilojoule mole inverse, and the bond length is 74 picometer. Moreover, since no unpaired electron is present in hydrogen molecule, so it is a diamagnetic in nature. You can see here there is what? Is there any unpaired electron in the bonding orbital? See guys, this is what? This is atomic orbitals. You might be confused in this. There is single bond, single electron is there. The single electron is there. So how you are saying that this is in pair? So this is atomic orbital. So atomic orbitals are combining to form the molecular orbital. Getting my point? So if I'm writing 1s, this is what? This is atomic orbitals. Again, if I'm writing 1s, it means what? This is what? Atomic orbitals. Because what we have done? We have done what? We have taken one H and another H. We are taking what? Guys, are you able to understand my point? 2H is there, they are combining, their atomic orbitals are combining, then the formation will be of what? Molecular orbital will be there. Getting my point? If this bottle and this pen will be combining, then there will be a formation of something else, right? So 1s, another 1s, they are combining to form sigma 1s2. Sigma 1s2. Getting my point? So this is what? A molecular orbital. Sigma 1s2 is what? This is a molecular orbital, right? And sigma star 1s is what? This is anti-bonding molecular orbital. Sigma star 1s is what? Anti-molecular orbital. Although there is no any electrons are filled there, so it is 0 electron is there in the sigma star 1s. Getting my point, everyone? So you may ask me another question, sir, when there will be the electron? So when there will be the electron, when the question will be coming according to that, then I will be showing you the number of electrons in the anti-bonding molecular orbital. Getting my point, everyone? Fine. Is there any problem? No. So we have found how we have found the number of that bond order we have seen, and how this is diamagnetic in nature that we have seen, right? So we will be continuing the class after the break. Have a break of 5 to 7 minutes. Then we will be come with some new topic, right? So stay tuned with me. After just 10 minutes, we will be starting once again. Are you there, everyone? Please turn on your camera. See guys, now we are going to look HE plus 2, right? Please turn on your camera, Nilambadi, Kaniska. Yes. Kaniska has opened. Those who have gone on long break, please turn on your camera now. I hope break is over. Nano break was there. Now you are using it like micro. 10 to the power minus 9 meter, 9, right? And macro is what? 10 to the power minus 6. So now guys, see here. So we'll be looking into what H2 molecule, right? H2 plus. H2 plus means what? How many electrons will be there? First of all, tell me that. How many electrons will be there? How many electrons will be there? He plus 2, H2 plus is there, right? So number of electrons will be what? Pranav, what do you say? 2 or 1? 2? No, 1 electron will be there. If plus charge is there, so number of electron will be what? 1 will be there, right? So how we will be writing? See, how to write the molecular, like molecular orbital configuration? How we are writing? Sigma 1s C. See how we are writing 1s, right? Do you know? In the last class only I have made you written that how we can write the electronic configuration of some elements. Do you remember, or you have forgot that? What should be the general rule to write the electronic configuration that I'm seeing here, whether I have made you written or not? Guys, do you remember how we can write that? Do you remember or not? First tell me that. If you are not remembering, then I will have to make you understand that first, then we will be writing that. Let's suppose if I have to write about the oxygen, right? Oxygen molecule, right? How I will be going to write that? How I will be going to write that? See here. Oxygen molecule, if I have to write, how I will be going to write? See. First of all, write sigma 1s. Sigma 1s, right? First of all, what we will be going to write? See, what you will be going to write? Sigma 1s. 1s2 is there, right? So sigma 1s2 is there, right? Then what you will be going to write? Sigma 1s, then star will be there, right? And again 2 will be there, right? Then what will be there? Sigma 2s, right? Sigma 2s will be there, and sigma star 2s will be there. Guys, this is simple. 1s2, 2s2, 2s2, right? So sigma star 2s2 will be there. 2s2 will be there, right? How we are writing in the atomic orbital? 1s2, 2s2, 2p6, yes or no? 1s2, 1s2, 2s2. Now, in P, what will be there? In P, in case of P, how we'll be writing? So in P, pi 2px, see guys. Actually here there is less space, so I have to minus here 2px, right? Pi 2px equals to pi 2py. Pi equals to pi 2py. Pi 2py. You may note it down. Pi 2p 2py. Pi 2py. Getting my point, everyone? Pi 2py. Clear, everyone? Now, in the last you have to write what? Sigma 2pg. Sigma 2pg. Clear here? So sigma star 2pg. You have to write what? Sigma star 2pg. And here, in case of pi also, star 2pg and star 2px and 2py. So this is the way we can write the molecular orbital electronic configuration. Sigma 1s2, sigma 2s2, sigma, then pi 2px, then equals to pi 2py, then equals to what? Sigma 2p, sigma star 2pz. And in between, you have to write all this. Getting my point? So we are going back into that what we have taught. Just see here. See, for H2 molecule, this is formed by the combination of hydrogen atom containing one electron and hydrogen ion have no electron. So hydrogen ion will be having no electron. So H plus will be having no electron, right? So that atom containing one electron and hydrogen ion have no electron. So therefore this ion has only one electron. The molecular orbital diagram that you can see here is what? 1s, 1s, right? Sigma 1s and sigma 1s star, right? This is for H2 molecule. This is not for H2 plus molecule, right? So the electronic configuration will be what? It should be what? 1s2, 1s2, right? But here there will be not 1s2. It will be what? Sigma 1s only. Getting my point, everyone? Is it clear to you? It should be what? 1s2, right? And then before that it will be what? Sigma 1s. But here there will be no 2 will be there. Here it will be what? Sigma 1s. And if sigma 1s is there, so there will be in bonding it will be what? 1. And in anti-bonding there will be what? 0. So because there is no any star in between that, so we will be taking what? Sigma 1s. So there will be 1 electron will be in the molecular orbital. So if it will be 1 electron, so 1 minus 0 upon 2, it will be what? 1 upon 2. The bond order will be 1 upon 2. Getting my point, everyone? So the bond order will be what? 1 upon 2 only. Easy? Now, if the bond order is 1 upon 2, if the bond order is what? 1 upon 2, it will be showing, or you can see here, there is 1 electron in the molecular orbital. So it is unpaired, because if there will be 2 electrons in this molecular orbitals, it will be in paired. So if it is unpaired, then it will be having what? It will be paramagnetic in nature. So you can see here, the positive value of bond order indicate that the molecule is stable, right? The presence of unpaired electron in the molecule indicate that it is paramagnetic molecule. Getting my point, everyone? Is it easy now? Any problem till here? Any problem till here, anyone? Now, so if it is paramagnetic in nature, so see here, the bond length He plus 2, H plus 2 ion is larger than H2 molecule. So the bond length will be what? Larger will be the bond length, right? So the bond length of H plus 2, H2 plus ion is larger than that of H2 molecule, and bond length H2 plus is 104 picometer and H2 will be having 74 picometer, while the bond dissociation energy is less. So we have seen that if the bond length is much, then the bond dissociation energy BDE is what? Lesser. That we have seen in the previous slides. Yes or no, everyone? What do you say? If the bond dissociation energy is larger, then the bond length is lesser. If the bond length is larger, then the bond dissociation energy is lower. Yes or no? Getting my point, everyone? Are you concentrated? Maurice, are you there? Please wake up. Good morning, Maurice. Are you there? Everything is fine? Guys, those who will be sleeping, I will be saying them good morning. Right? So Maurice, is it fine for you? Understanding the parts that I am discussing here? Any problem till here? Any problem till here, anyone? No problem. Okay guys, now come to the point. Next, come again. See, is it easily understandable or not? If you are finding anything difficulty, then please come up with me. Then I will be explaining in different manner. Even if I will be having some different ways to teach you, I will try my level best to make you understand, guys. Because if you are joining for these 2 hours with me, it means that must be fruitful for you as well. Getting my point? You are investing lots of money. You are investing your time. So if you are not getting this, like you are not getting from here, then it will be, it will be a question mark on me also, right? So what do you want? Getting my point, everyone? Is it easy now? Why this H Atachaya will be explaining this time. Why this H plus, sir, every time you are taking me, sir? Why you are doing like this, sir? No, this is not good at all. So why H plus? If you are giving me the correct explanation, I will be really very happy this time. Why H2 plus ion is paramagnetic in nature? Guys, prepare your answer. I can ask anyone. So be ready for the answer.
Because there is an unpaired electron, so
In where there is an unpaired electron is there?
The molecules.
Very good answer. Yes, you are going
the
good.
molecule, the unpaired electron is present, so it is paramagnetic molecule.
And what will be the molecular configuration for this? It should be sigma 1s2 or sigma 1s only.
Sigma 1s1.
Very good answer. Very good answer. Give a big hand for her, guys. Everyone, please give a big hand for Atachaya. She has understood very well and she has explained in a really very good manner, right? Everyone. So same answer was for with everyone for this question. You were thinking the same answer that Atachaya has given. Yes, I know that everybody will be saying yes, sir. Yes, sir. If the correct answer will be there, right? So everybody, yes, sir. I was thinking for the same, sir. I was thinking for the same, sir. Even if you are thinking the wrong one also, yes, sir. I was thinking for the same, sir. Yes, sir. Yes, sir. Guys, I have also done my, I was also there in the coaching institute. I was also doing the same, right? Even I was not knowing the answer. Yes, sir. She is correct, sir. She is correct. Getting my point. So no problem. Okay. If you are getting, then it's really fine. Really fine. Now, come to the next point. So now guys, see here. So hypothetical helium molecule, guys, although why I am saying hypothetical means what? That is not correct, real. Hypothetical means what? That is not real. That is what? That is imaginary. You might be heard in your physics as well, hypothetical or pseudo you can say. So He2 molecule, although not existable, because I have told you in the earlier only, He is there, right? Because that is the He molecule has completed its duplet, so there is not existence, there will be no any existence of He2 molecule, right? But hypothetically we have imagined for that, and accordingly we will be going to find each and everything for that. Getting my point, everyone? So see here. Hypothetical helium molecule He2. Each helium atom has 2 electrons in 1s, right? Orbital, and therefore there are 4 electrons in He2, right? Because He will be combining. He will be combining, right? So one He atom is having how many electrons? 2. So these 2 will be combining. So they will be forming what? Molecular orbital. See. So He2 molecule will be formed. These electrons will be accommodated in sigma 1s and sigma 1s. Sigma star 1s, right? You can see here sigma 1s, right? So two electrons has been combined, right? So sigma 1s has been filled here, right? So now you can see here sigma star 1s. These electrons will be accommodated. So 4 electrons are there, right? You can see here 4 electrons are there. Getting my point, everyone? So you may ask me another question, sir. Here you have seen only 1 electron here, right? 1 electron here. So 1 electron is here, guys. So why I will be writing here 2? If it will be not filled, then how I will be writing this? How I will be filling this? Getting my point? I think there might be some bulb has been blown. There might be some sparkle of light. Yes or not, guys? See, I'm comparing this diagram with this diagram. See here. See here. Here there is 1s, right? Here there will be 1s. I can understand that you might be facing some problem. Even I will be comparing with this now. I will be comparing with this 3 diagram, and now I will be confirmed that you will be getting my point. First of all, H molecule, H2 molecule, right? Then H plus molecule, right? Then He molecule. Getting my point, everyone? H2 molecules. It means what? It means what? See here, figure, please. Yes, see here. You will be able to understand. 1s will be combining, another 1s will be combining. So there will be sigma 1s will be there. What will be there? So you may be asking, sir, here there will be anything? No, because 2 electrons has been combined. Because first of all, lower energy will be filled, right? You can see here in the bottom line, there will be a lower energy orbitals will be there, lower molecular orbitals will be there. So that has been filled. 2 molecules, 2 electrons has been filled there. Getting my point, everyone? So if this will be filled, then only we'll be jumping to the next one. So you can say that in anti-bonding molecular orbitals, there will be no any electron will be there. Getting my point? If 1s and 1s has been combined, so it will be forming what 1s2, not 2s2. It will be 1s2. Getting my point? So for this H2 molecule is this. Getting my point, everyone? Now see here, for this H plus. So only one electron is there. Only one electron is there. So I will be writing only 1s here, and one sigma 1s will be there, right? Sigma 1s will be there, and here there will be no electron will be there. So what you have to write in the left hand side 1s, in the right hand side 1s, in the bottom line what you have to write sigma 1s, right? It will be written already, right? You have to write all these things already, right? In the above line you have to write what? Sigma star 1s. Getting my point? If the electron will be filled in that, accordingly you have to write. Either if one electron will be there, then sigma star 1s1. If there will be 2 electrons will be filled, then sigma star 1s2 will be there. So you might be seeing here that there is no any electron in this. So but although I have written this, but there is no any electron, so there is no use of that. Here there is an electron, that is sigma 1s is there. So H2 and H2 plus, I hope this is clear now. Now we are moving to the He molecule. That is a hypothetical molecule that we are going ahead, right? See here. So 1s, 2 electrons of this and 2 electrons of this, they will be combining. So the total number of electrons will be what? 4. So 2 electrons is here and 2 electrons is here. You can see here. Getting my point, everyone? So total number of electrons that will be combining will be what? 4. So 2 electrons, 2 molecular orbitals, right? One will be participating in bonding, another will be participating in anti-bonding. So 2 electrons will be in the bonding molecule and 2 electrons will be in the anti-bonding molecule, right? So for that bonding we will be write what? Sigma 1s2, and for anti-bonding we will be writing sigma star 1s2. Getting my point, everyone? Easy for everyone or not? For anti-bonding what we will be writing? For anti-bonding what we will be writing? Sigma star 1s2 or not? For anti-bonding sigma star 1s2. Is it easy now? Okay, fine. See guys, so you can see here 1s, 1s, so it is what? 1 sigma 1s. Now here there is what? Sigma star 1s. Getting my point, everyone? Sir, why was not? Sir, I was not. Oh, Modest, no problem. Okay, I was kidding only, Modest. Don't take it like seriously, right? It was only for the fun for the class, because all were like, lazy in the class. So that's why I have told these things, right? No problem. Don't take it seriously. I'm always in a funny mood in the class. So now guys, see here. So each helium atom has 2 electrons, 1s orbital, and therefore there are 4 electrons in He molecule. These electrons will be accommodated in sigma 1s and sigma star 1s. So molecular weight is shown that you can see here. The electronic configuration will be what? Sigma 1s2 and sigma star 1s2. So you can see 2 electrons, 2 electrons. One will be in bonding, another will be in anti-bonding. So total number of electrons in bonding and anti-bonding will be what? First tell me this. Who will be telling me how many electrons are there in bonding and how many electrons are there in anti-bonding? Please write in the chat section. Please write in the chat section, everyone. How many electrons are present in bonding? If I have written this molecular configuration 1s2, sigma 1s2 and sigma star 1s2. So how many electrons are there in bonding and how many electrons are there in two bonding and two bonding? Only Atachaya is getting the answer. 2 each, very good. Kaniska also getting good. 2 each, very good answer. Other people, please write in the chat section. Ilambri 2, yes, very good answer. Others, please give me the answer. Do fast. Mukeshwar, only not 2 will be there. Pranava 2 will be there. So if NB minus NA will be there, if NB minus NA upon 2 will be there, so can we write 2 minus 2 upon 2? It will be what? 0 upon 2. It will be what? 0. Yes or no, guys? So the bond order will be what? 0 only. I hope everybody is now understanding. Everybody is understanding now. Yes or no, guys? So now you can see here Now you can see here NB minus NA, 2 minus 2 upon 2. So the right answer is what? 0. So you have given me the same answer. So the bond order will be what? 0 only. If the bond order is 0, then what kind of molecule it will be? Either it is a paramagnetic or diamagnetic in nature. See here guys, 0 bond order value indicate that there is no net bonding and He molecule should not be formed. It means what? That will be not either paramagnetic or diamagnetic in nature. It means that if bond order is 0, it means that then the molecule will be not formed. And earlier also I was saying the same thing, that there will be no formation of He molecule, no formation of Ne2 molecule, not formation of Ar2 molecule, not formation of Xe2 molecule. Why? They are all inert. They are all there. Their octet has been already completed, so there will be no formation of inert gas molecule. Getting my point, everyone? Am I clear here? Am I clear here? Where is Anil Dev? Anil Dev, tell me where Xe2 molecule will be formed or not? Xe2 molecule will be formed or not?
No, sir.
Why not one? I am saying
Gas.
yes, it will. Yes, noble gas. So why it will be not formed?
There is no electrons to share.
Yeah. So there will be no electrons to share. So bond order will be what? 4, 5, 6, 8.
Bond order is 0.
0, sir. Yes. So you have to correct me, sir. No, sir. You are saying wrong, sir. Not 4, 5, 6, 8, sir. It will be 0 only, sir. Getting my point? Okay. Where were you, Bhuana? You have left the class or what? Bhuana, are you there? Have you left the class or what? Okay, guys. So now you can see here that net bonding is He molecule should not be formed. In fact, there is no experimental evidences for the existence of this molecule. So there will be no formation of this. No. He molecule, helium molecule ion, He plus 2 ion, right? This molecule contains the electrons, 3 electrons. This molecule contains 3 electrons, 2 from one helium and atom and 1 from the other He plus ion, right? The molecular orbital electronic configuration of the molecule will be what? Sigma 1s2, sigma 1s2, right? And sigma star 1s2. Getting my point, everyone? See here. How we will be writing the electronic configuration for this? He plus, He2 plus, right? So one will be what? Sigma 1s2, right? And another will be what? For anti-bonding, what we will be writing? Sigma star 1s, 1 will be there because what? There is plus charge is there. Yes, plus charge is there. So if plus charge will be there, so 1 electron will be lesser than the count. So it will be what? 1s1 only. So sigma star 1s1 will be there. Sigma star 1s1 will be there. So what will be the bond order then? Bond order will be what? Bond order will be what? Na minus Nb. Na minus Nb upon 2. So what is Na? Na is what? That is 2. 2 minus 1. Yes, guys. 2 minus 1 upon 2. It will be what? 1 upon 2. Yes or no? Whether it will be a paramagnetic or diamagnetic nature. What do you say? Paramagnetic or diamagnetic nature. Guys, if it is in what? It is in unpaired in the molecular orbitals. So it will be in what? Diamagnetic nature. Sorry, if it is in unpaired, so it will be paramagnetic in nature. So in the what? 1s sigma star 1s1 is there. So it is what? It is unpaired, right? If it could be sigma star 1s2, so it will be what? It will be diamagnetic, but here it will be what? Paramagnetic in nature. So you may see here that the value of bond order indicates He plus 2 is stable. Its bond or dissociation energy has been found to be 248 kilojoule mole inverse. You don't have to learn this data. The molecule is expected to be paramagnetic and same has been experimentally observed also. Getting my point, everyone? Easy to memorize or not? Very good, Atachaya. Paramagnetic. Very good, Anil Dev. I hope you are understanding, guys. If you are understanding, then I am happy. If you are not, then I am not happy. Guys, if you will be concentrating on class, definitely you will be understanding, right? How Atachaya, how Kaniska, how Anil Dev, how Pranab, they are understanding the class. They are really very understanding the each and every moment of it. You have to just you have to just give your 100% here, right? Sometimes you are not understanding, I know well, so there is a difficulty level of the class as well, and there might be something, different teachers have having different approach to make you understand, right? So sometimes if your frequencies are not matched with the teachers, so the things will be not getting inside, right? So you have to set your frequency to match that frequency, right? Now come to the next point. What is here? For lithium molecule, we are going to see about what lithium molecule, right guys? Hydrogen, helium, lithium. Hydrogen, helium, lithium, right? How we'll be writing? So total number of electrons is what? 6, right? Total number of electrons is what? 6. So it is very easy to write the molecular orbitals, molecular electronic configuration. So the configuration how we will be writing, that is what? Sigma 1s2, then sigma star 1s2. So total number of electrons is 4 till here. Then again sigma 2s2. Yes or no? Sigma 1s2. Then sigma star 1s2. Then sigma 2s2. Total number of electrons will be what? 6. They will be combining only. In atomic orbitals, what we are writing? 1s2, 2s2. For lithium, what we are writing? 1s2, 2s2. Yes or no, guys? What do you say? But in molecular orbital, molecular configuration, what we will be writing? 1s, sigma 1s2. Only the word that has been introduced is what? Sigma. Sigma 1s2. Then sigma star 1s2. Then again sigma 2s2. Then again sigma star 2s2. But here there is only 6 electrons is there. So there is no need of sigma star 2s2. Getting my point? So what will be here? Sigma 1s2, sigma star 1s2, sigma 2s2 will be there. So this is the electronic configuration for lithium, right? Getting my point, everyone? Easy? Now, what will be the bond order then? What will be the bond order? So you can see here, in anti-bonding will be how much electrons are there in anti-bonding and how much electrons are there in bonding. So you can see here, this is in bonding, this is in bonding, but here it is in anti-bonding. Wherever there will be a star will be there, wherever there will be a star will be there, that will be in anti-bonding. So 4 minus 2, it is what? It will be what? See here. It will be what? 4 minus 2 upon 2. So it will be 1 only. So what do you say about the paramagnetic nature or dimagnetic in nature? Paramagnetic nature or dimagnetic in nature? What do you say? Who will be saying me? Anil Dev is saying paramagnetic. How, Anil Dev? How it is paramagnetic in nature? How you can say this is paramagnetic in nature? Can you say me? How it will be paramagnetic in nature? Anil Dev? Oh, I don't know answer, sir. It was for previous. Okay, no problem. See guys, actually this is what? Total number of electrons that is in the last orbital is what? That is 2. So it will be dimagnetic in nature, right? Now, come to the next point. The sixth example is what? About the beryllium molecule, Be2 molecule, right? Beryllium molecule, right? See, the atomic number is what? Hydrogen, helium, lithium, beryllium. 4th number, right? So it is coming at what? 4th number. So electronic configuration is what? 1s2 and then 2s2. Getting my point, everyone? Getting my point? So what will be the molecular configuration? Molecular electronic configuration. It will be what? Sigma 1s2, right? Then what will be there? Sigma 1s2. Then can we write sigma star 1s2? Getting my point, everyone? Easy. So configuration of 1s2, 2s2 informations of each atom, that is 4 in all above 2, right? 4 in all above 2. So sigma star 1s2, right? Getting my point, everyone? So accommodated in the molecular orbitals, 2 of these go into the bonding, that is sigma 2s orbital, while the other 2 have to go into the anti-bonding, that is sigma star 2s. Getting my point, everyone? Easy? Now, so the what will be the bond order then? Bond order will be what? Bonding minus anti-bonding. Bonding minus anti-bonding will be what? 2 minus 2 upon 0. Sorry, upon 2, it will be what? 0 upon 2, it will be what? 0. So that Be molecule does not exist. Why? You know well that Be2 will be not existing. Why? Because Be is already a completely filled orbitals are there in Be. Getting my point? It's a kind of duplet, you can say that it is forming. So Be2 molecules will be not formed. Getting my point? If the bond order is 0, if the bond order is 0, it means that compound will be not existing. Getting my point? The molecule will be not existing if the bond order is 0. Easy one? No. Next example is boron molecule, right? So it is very easy, guys. Sigma 2s2, sigma 2s2 star, pi 2px and pi 2py again. Why this come into the picture? Oh my God, we are having so many examples we have taken for this. Okay, we'll be seeing first the example, and whatever be the thing that will be left in today's class, and in the next class there is no any class, that is not any class means there will be a chapter assessment will be there. So guys, be prepared about your chapter assessment, because again the time has come up for you to become an educator of the class. In the next class there will be another round of the educator of the class. So I want to say you to make a prepare of your each and everything very neat and clean, or you can have a proper note of everything, right? Let's suppose if you have to give the demonstration of anything, if you want to teach anything, have a preparation of that in a white sheet or in a notebook or anywhere, and make a proper note of all that. Like, you must be confident. You can do one thing: be stand in front of a mirror and have a preparation of any topic and teach like a teacher in front of the mirror. And you have to behave. Yes, mister, you are not understanding the class. Where are you? Why are you not listening the class? Getting my point? So you have to behave like this, right? Getting my point, everyone? Easy. So be ready for the next round. That will be what? The educator of the class round will be on the next Thursday. Next Thursday will be that chapter assessment will be there. So that's the opportunity to become an educator of the class. Getting my point? This is the award that will be given by me in the live session only. Okay, guys. Now come to the next point. So beryllium we have seen, right? The bond order is 0. That will be not existing. For boron, see here. The electronic configuration of boron is what? 1s2, 2s2, 2p1. The total number of electrons in the boron is what? 5. 1s2, 2s2 and 2p1 will be there for what? Boron molecule. Boron, not molecule, boron, right? Now we are going to do what? We are going to find the molecular configuration, or you can say that molecular orbital electronic configuration. Molecular orbital electronic configuration for this boron will be what? That we are going to discuss. Getting my point, everyone? The outermost shell of each atom contains 3 electrons, right? The outermost cell is what? 2s. That is 2. Second cell is having what? 3 electrons each. So when these two B atoms combine to form a molecule B2, there are 6 electrons. Each need to be accommodated in the molecular orbitals of B2. Getting my point? The molecular orbital configuration is what? Sigma 2s2 and sigma star 2s2, right? Then what will be there? Pi 2py1. Pi 2py1 will be there. So again, see here what will be there. So total number of electrons in bonding minus anti-bonding will be what? Anti-bonding 2 electrons is there, right? And total number of electrons in bonding will be what? 2s2. So what do you say? What will be the right answer for this? pi is there, right? Pi is there. So what will be? So what will be the right answer? Boron molecule, what do you say? Pi 2py is there. If here is the, yes, very good. Anil Dev, what do you say? So 4 minus 2, what do you say? 4 minus 2, right? 4 minus 2, right? So 4 minus 2 upon 2, it will be what? 2 minus 2. Getting my point? It will be what? 1 only. So it will be what in nature? If 1 will be there, then paramagnetic in nature. Here there is some mistake, guys. Actually here there is what? Actually 1 has been given. Okay. 4 minus 2. Okay, fine. Paramagnetic in nature now. Carbon molecule, C2 molecule. Getting my point, everyone? Sigma 2s2, sigma 2s star 2, right? And pi 2px and pi 2py will be there. Pi 2px and pi 2py will be there. So total number. And how many electrons are there in the bonding and anti-bonding orbitals? See here, the electronic configuration of electron carbon is what? 1s2, 2s2, 2p2, right? The outer shell of each atom contains 4 electrons, right? So 4 electrons are there, right? In the formation of C2 molecule, there will be eventually we are seeing 8 electrons to be accommodated in the outermost molecule orbital of C2. So how it will be formed? That bond order will be what? If 8 molecules, if 8 will be there, then in this case we can see here 0 minus 2 will be there. So minus 2 will be there. Thus the C2 molecule has 2 bonds. The bond dissociation energy C2 molecule has been found to be 620 kilojoule and bond length will be 131 picometer. Getting my point, everyone? See guys, actually what will happen? This pi will be cancelling it out, right? Pi will be, this pi 2px will be cancelling this pi 2py. Getting my point? So total number of anti-bonding will be what? That will be 2. Easy one. Now, so it will be a, now you can see here, so minus 2 is there, then it will be a diamagnetic in nature. Further, since C2 molecule does not have any unpaired electrons, so it will be the diamagnetic in nature. Now, you can see here, it may be noted that the double bond in C2 molecule consists of both the pi bonds because of the presence of 4 electrons in 2 pi and molecular orbitals in the most molecule double bond in the made up of sigma and pi bonds.